Okay, so here we're using an ICE chart to find KC values given initial values at equilibrium. So when we're using an ICE chart, you have to have initial values given, and then we set it up, figure out what our values could be at equilibrium, and then equilibrium and KC are directly related. So once we have those equilibrium concentrations, we can plug it into the KC expression. So let's set this up. So setting up ICE, the I is always your initial concentrations. So initially you have H2 and I2, so 0.100 moles of each. And then unless it tells you otherwise, if you're not given values for the product, you can assume the product is 0. The C is your change based on the mole ratio. So the concentrations are going to change, and we don't know what it's by, but it is by a ratio. So reactants are used up, so you subtract them. And I'm just subtracting 1x because there would be a 1 in front of the hydrogen and the iodine. And then products are being formed, so you add them in. So this time it's 2x, and that 2 is coming from the 2 out front of the HI. And then to get your equilibrium concentration, you add your column together. So 0.100 minus x, 0.100 minus x, and then this one would just be 2x. Now, to figure out the KEQ, we need to know these values at equilibrium, and we're going to use the information that at equilibrium we know the concentration of I2. So we can take this value and set it equal to 0.020 and solve for x. So if we move over the 0.1 and divide by -1, you'll get that x will equal, sorry, I just don't have my calculator here, you'll get x equals 0.08. So once you know what x is, then you can plug it in for each of your values, and then we'll know the concentration at equilibrium. So now we can set up the KEQ expression. So you have products concentration, and then squared, because of the 2 in front, divided by your reactants concentration. We don't need any exponents because we have just a 1 in front. Once we have that, then we can start to plug in the values we calculated at equilibrium. So HI would equal 0.16, and this needs to be squared, divided by 0.02 and 0.02 for each of those. Now you can plug that into your calculator. If you're dividing all in one step, just make sure you have those extra brackets in the denominator. And when you're done, you should see the value 64, and K values, that constant, they do not have units. So then that one is done. So that's how we can use an ICE chart given those initial concentrations to come up with those equilibrium concentrations to calculate KEQ. I hope you found this helpful. If you did, please like and subscribe.